All right, guys, we're ready to move into example 4, part A for binomial distributions. In case you're wondering, I've chosen to skip example 3. It doesn't really show anything terribly different, but this has several parts that'll take us through how to reason our way through these different types of questions. Let's talk about flossing, all right? So anyway, I read somewhere that 59% of Americans floss every day. That's an estimate. We'll get into that later in the semester. But anyway, suppose we sample 15 people, and we want to talk about the number of people in that group of 15 that floss every day. Notice it mentions flossing. First of all, the 15 would be the N in this example because, again, each of those individual 15 people would have their own response as to whether they floss or not. Binomial, you either floss or you don't every day, all right? But since the question mentions flossing, that would be considered success. And if we're to believe that estimate, that would be 59%, otherwise known as 0.59. Therefore, the opposite of that, people who don't floss every day, 41%, I took that away from 100%. So I'm here to tell you if you don't floss every day, you're a failure. By the way, I don't floss every day. I'm a failure. I'm left-handed. I'm not left-handed, sorry. I don't floss. I guess I'm really a big failure. But anyway, that would be the N, P, and the Q for this particular situation. All right, so I always like to look at it in full context. If you survey 15 people and ask them if they floss every day, you could have anywhere from 0 to all 15 that floss every day. That's the set of numbers that X could possibly be, where X is how many people in that group of 15 floss every day. So it's a matter of identifying which numbers fit the question. Well, here it says, what's the probability that exactly 2, wouldn't that just be the individual number 2 here, right? Exactly 2 of those 15 people floss every day. So that would be written as the probability that the number of people who floss is equal to 2. That's an individual number in that range. So I would just look at it and go, okay, all I got to do is set up that probability for 2, and I'm good to go. So, just like we've been doing earlier, we say, all right, hey, I'm going to give you a group of 15 people. You can choose any 2 to be flossers, and I don't care what order. So that would be the combination of 15 choose 2, which I'll remind you is just a calculator function that we showed you how to use before spring break. All right, and then flossing, which is 0.59, that would be 2, wouldn't it? 0.59 to the second power, 2 people floss, which means the other 13 people, remember there were 15 people surveyed, so the other 13 do not floss. 2 people floss, and 13 do not. Crunch, crunch, crunch with the calculator, and that would give you the number that I'm about to write on the board, all right? And so I worked this out ahead of time, and again, I'm hopeful that I can read my own writing. But if you crunch those numbers, you should get something along the lines of 0.000333812. As I keep saying, I don't care how many decimals you keep. Why don't we end this one with a little bit of entertainment about flossing? So here's a clip I found by one of my favorite comedians, Mitch Hedberg, about flossing.
I can't floss my teeth anymore. I can't get into the flossing thing. People are so serious and say, man, you don't know how hard it is to quit smoking. Yes, I do. It's as hard as it is to start flossing. You seem jittery. Yeah, I'm about to floss.
All right, we'll be right back for part B.